All right, so we're on page 5, and we've got points, lines, and planes is the name of this section. And you see I've got up here our 2 learning targets for the day. Now, at the beginning of each unit, I will give you a handout with all of the learning targets. Okay? The learning targets are the content that you will be assessed over. The quizzes and the tests are based on the learning targets. Now, as you can probably imagine, in math, and especially in geometry, there are a lot of foundational things that you need to know that aren't part of the actual standards for this class. So I don't teach you just the learning targets. I will teach you other things to help you understand the learning targets. The learning targets are our goals. We will have to learn things to get there sometimes. You know what I'm saying? And sometimes we don't. Sometimes it's just flat out the learning targets. But most lessons will have things that lead us to the learning targets. If it's not part of a learning target, it won't be a quiz question. Okay? So all the quiz questions and test questions address at least one learning target in some way. So that's why I want you to be familiar with the learning targets, because it helps you know what to study when it's time to study. Okay? It also helps you know what to focus on today, because I'm going to talk about some things today that you already know. And so you can think, okay, I already know that, that's good. And you can think, okay, he's talking about this, it's not part of a learning target. That means I need to know this to better understand the learning target. You with me? All right, so I always give you the learning targets, and I always put them up here on the screen when we start, so we don't just blow them off. They're kind of important. So we're going to be able to describe the undefined terms, point, line, and plane, and we're going to use objects to model geometric figures. All right? Both of these things are fairly doable. So let's take a look at page 5. They tell us here at the beginning that unlike the real-world objects that they model, shapes, points, lines, and planes do not have any actual size. In geometry, point, line, and plane are considered undefined terms. Now, let me stop there before I finish the rest of this sentence. Have you ever had this experience? It's more likely to have happened with people my age than with people your age, because now you've got so many things you can look up online. But have you ever had this where you didn't know the meaning of a word, so you looked it up in a dictionary, and in the definition was another word you didn't know, so then you looked that one up, and it refers you back to the one you were looking up to start with, so you never really did learn what the word meant? In mathematics, we really want to avoid that, okay? So to use a word in a definition, we have to already know what it means, okay? So in math, definitions are very precise. They're very wordy because they want to make sure that their definition tells you exactly what you need to know. Now, the worst part about this is, look at this. Point, line, and plane are considered undefined terms. They don't have a dictionary definition because they are only explained using examples and descriptions. So the very basis of geometry are these 3 undefined terms. And that seems a little scary at first until you realize the only reason they're undefined is because mathematicians cannot agree upon a definition. It's not that they don't know what they are, and it's not that you don't know what they are. It's that mathematicians could not agree upon a definition. Okay? So that's why they're undefined. But you know these things. You know what a point is. A point is a location. It has neither shape nor size. Now, when we make a point on our paper, we do like the book did here. We make a little circle, we color the circle in, and then we always name a point a capital letter. So I can call that point D. Okay? But here's the thing. That point doesn't really have a shape. We always make them circular, but if I'm in a hurry and I kind of make it oblong instead, is that okay? Yeah, it's not as attractive looking, but that's okay. All right. If I've got all the time in the world, and instead of making a circle or an oblong, I want to make a star. Can I do that? Yes. Because points don't have any definite shape. They don't have a size either. Like if I put a point up here on the board, and then I realize that all you guys are squinting and you can't see it, I'll probably come back and make it a little bit bigger. The point didn't actually get bigger. It's just that my drawing of it is now bigger. Okay? So points don't actually have a shape. They don't actually have a size. They just tell you where something is. It's a location. All right? That's all a point is, a location. No shape, no size, just a location. Okay? So where's point A? Right there is where point A is. It's that location. Make sense? All right, now a line. You know what a line is. A line is made up of points. Now, since points don't have any size, lines can't have any thickness, can they? So, a line is made up of points and has no thickness or width. There's exactly one line through any 2 points. Now, lines go on forever, and lines are made up of points. See on this line here that you see point P and point Q? P is a point, Q is a point. They're not actually larger than all the other points. The book drew them larger to draw your attention to them, P and Q. And then all these points in between them make the line. And then you keep going out on the other side of Q, keep going on the other side of P, and that's a line. So a line's just made up of points, an infinite number of points. The points have no size, therefore the line has no thickness. To name a line, and the way we name things is going to be a fairly big deal, okay? You've got a couple different ways you can name a line. One thing you can do is just put a lowercase letter next to it and call it that. So put an M next to the drawing of the line and call it line M. Another thing you can do is pick out any 2 points that are on the line and name it line those 2 points. So in other words, P and Q are the 2 points we know. Call it line PQ. Look at the notation. It's a P and a Q with a little line symbol above it. Order doesn't matter. So calling it line QP is just as valid as calling it line PQ. Now, you do have to put the little line symbol above it. Because, look, let me show you something here. Here's what we're going to have within just a matter of days. We're going to have this, which means line PQ. We're going to have this, which means ray PQ. Lines and rays are not the same thing. We're going to have this, which means segment PQ, which is different than a ray and is different than a line. And we're going to have this, which means the length of segment PQ. So that'll be a number. So all 4 of those things that you see on the screen are different. You've got to get the notation right. The book has to get the notation right, or it becomes confusing. Because a line and a segment of a line are not the same thing. Lines go on forever. Segments don't. They stop. They're measurable. And then the last one, the length of segment, that's even different. That will be a number. All right, the length of segment PQ is 7 inches. It's a number. Okay? So you got to get them straight. Now, when we're talking verbally, I'm lenient on saying line instead of segment, because when we're talking to each other in the context of a problem, and I say, now look at PQ. If the problem's talking about the segment PQ, you'll know I mean segment. If the problem's talking about line PQ, you'll know I mean line. So I'm a little looser on this when we're talking to each other. But when you write it, you must use the correct notation. If there's a quiz problem, and the answer to the quiz problem is line PQ, and you write segment PQ, I will count it wrong. You know why I'll count it wrong? Because it's wrong. You with me? All right. So we've got points, we've got lines. Our third undefined term is plane. Now, you've always heard of a plane being a flat surface, and it is. So, nothing new. So, the book says a plane is a flat surface made up of points that extends infinitely in all directions. All right, let's stop there. You've probably heard at some point something like this, that the floor is a plane. And we'll say that. What we really mean is, since the floor is a flat surface, it can be used to model a plane, or it can be used to represent a plane. But the floor is not really a plane, because the floor eventually stops, doesn't it? At the edge of the building, the floor stops. Well, the plane that the floor is representing, the plane itself, keeps on going. If you're a football fan and you watch on Sunday afternoons or Saturday afternoons, and they talk about it, somebody scoring a touchdown because the ball, they had possession of the ball and it crossed the plane of the goal line, there's a vertical plane, imaginary, rising out of the goal line, and I never have to cross it. If I'm the ball carrier, all I have to do to score a touchdown is have possession of the ball and reach out and cross the plane of the goal line with that ball. That's a touchdown. Okay? So even in real life, you have to know what a plane is. Well, because football is real life. Right? So you're with me on a plane. It goes on forever. Now, when we draw a plane, well, we can't draw forever, right? So we draw planes like this. We draw them to look like parallelograms. But they're not really. That's just for us to see it. Okay? Because parallelograms have edges. Do planes have edges? No, they go on forever. Okay? And I don't know why mathematicians decided to use parallelograms to represent planes, but everybody does. So we do too. Now, to name a plane, the simplest thing to do is in your parallelogram, which is just an imaginary plane. Parallelograms have edges, planes don't. Stick a capital letter in the corner, any corner you want, and call it that. So since they put a capital K in the corner, the simplest name for this plane is plane K. Alternatively, you can name a plane after any 3 points that are not on the same line. So points B, C, and D are not on the same line, so we can call it plane BCD. And it doesn't matter what order you put B, C, and D in. CDB is okay, DCB, DBC, CBD, doesn't matter. Just pick 3 points that are not in the same line and name the plane that. So, best way is plane K. That's the easiest, right? But any 3 points not in the same line also work. Now, this next part's a little harder to understand. It says there is exactly one plane through any 3 points not on the same line. Well, let's look at the screen here. B, C, and D are 3 points not in the same line. They are contained in this plane that contains the screen, aren't they? Okay? Just to keep it simpler, I'm going to say the screen is a plane. The screen's not really a plane because the screen ends and the plane doesn't, but we'll just talk, okay? If there was another point right here at the end of my finger, is there any way to get a flat surface that contains the end of my finger and the entire screen? Can't be done, can it? Okay? So for 3 points that are, well, so if you've got 3 points here, there's only one plane that contains them. Because if I have a plane that contains the end of my finger here, and it tries to go through it can't contain all 3 of them. It can contain 2 of them, but it can't get all 3. So we say it this way. We say 3 points determine a plane. Because there's only the one plane that contains them. I can't put another plane through there that contains all 3 of those points, can it? It can't go through here and all 3 of those. It can't be done. Okay? Can you visualize that? It's a little tougher than what we've talked about so far. Thinking in 3 dimensions, even though we live our life in 3 dimensions, thinking in 3 dimensions is a little more difficult than thinking in 2 dimensions. It just is. You'll get good at it you'll get good at it by next week. But it is a little more difficult. All right. So, point, line, and plane do not have definitions. but that doesn't mean we don't know what they are. A point is a location. A line is made up of points that has no thickness or width, and it goes through, well, and then you can get one line through any 2 points. A plane is a flat surface that goes on forever, and any 3 points not in the same line, there's only one plane that contains them. Okay? So, those ideas, those descriptions, those examples are part of your learning targets, so you need to understand what we've done so far. So are there any questions? All right. When we turn the page, no, actually at the bottom of page 5 still, we have 2 definitions that are not part of our learning targets. But you're going to need to know these words, otherwise there will be times you will not understand the book and you will not understand me. Because the book will use these words, I will use these words. Here's the first one, collinear. Collinear points are points that lie in the same line. So if collinear means they're in the same line, non-collinear means they're not. So non-collinear points do not lie in the same line. Let me give you some examples here. If I put point A and point B, they're collinear automatically. No matter where I put 2 points, can't I always draw a line through them? So 2 points are always collinear no matter what. But if I throw a third point in here, point C, if I line it up so that I can make a line that goes, a line now, not a curve, a line that goes through A, B, and C, then they're collinear. But if I put point C here, there's no line that can go through all 3 of those points, is there? I can make a line through A and B, I can make a line through B and C, through A and C, but not one line that goes through all 3 of them. Now A, B, and C are non-collinear. See the difference? Same idea with coplanar and non-coplanar. If points are located in the same plane, they're coplanar. If it's impossible to make them all in the same plane, they're non-coplanar. So, coplanar points are points that lie in the same plane. Look how you spell this word. It's A-R at the end. You expected E-R, right? But it's not, it's A-R. Non-coplanar points do not lie in the same plane. So, back to this figure, points B, C, and D are coplanar because they're in the same plane. If I put point E up here, outside of those imaginary boundaries, E is non-coplanar with the other 3. So B, C, and D are coplanar, but B, C, D, and E are non-coplanar. Now you might think to yourself, yeah, but you already said that planes actually go on forever, and if you just drew the boundaries of plane K a little bit further up, E would be on there. Well, you're right, because it's impossible to draw non-coplanar objects on a flat piece of paper. What I'm trying to show you with this drawing right here is this kind of thing, where this paper would be plane K, and then point E would be up here somewhere. Okay? That's what that drawing is trying to show you. It doesn't show you that all that effectively, does it? So you got to learn to look at the drawing and see what it's trying to say. If I put a point down here, then I'd be trying to show that here's your plane, and then the point that we're talking is down here. So since we can't actually draw it perfectly, that's the way we do it. We make the imaginary boundaries of the parallelogram, and then we just put a point that's not on that plane above it or below it. Okay? All right. Intersection. You probably know what the intersection of 2 lines is. But I don't think you know, maybe you know, what the intersection of 2 planes is. Here's what the book says. I'm on page 6 now. It says the intersection of 2 or more geometric figures is the set of points they have in common. It's the set of points they have in common. So if we look at this drawing here of line L and line M, the only point those 2 lines have in common means they both have it, is point P, isn't it? So whenever two lines intersect, there is a single point of intersection. But look over here. If two planes intersect, I don't see just a single point they have in common. I see a bunch of points they have in common. This red point I just drew in right there, isn't it in plane A and in plane B? And this red one right here I just put in, isn't it in both planes? As well as this one, and this one, and this one. And since the planes don't really have boundaries, if I extended the planes, wouldn't that one be in there as well? I'm getting a line, aren't I? If two planes intersect, they don't intersect in a point, they intersect in a line. And that sounds confusing, and the drawing might be confusing. So look up here. Let this wall represent a plane. Let this wall represent a plane. Where the two walls meet, what do you see? You see a line, don't you? So if two planes intersect, and they don't have to intersect, like the front wall and the back wall don't intersect, but if two planes intersect, their intersection is a line. All right? Any questions so far? Good, because we're ready to do some examples from your assignment today. Many of you have been taking notes as I've been talking. Good for you. And I don't require you to, because some folks have a hard time paying attention and writing. Now, you need to get past that, because the further you go in school, the more important it's going to be that you're able to do both those things at the same time. But I know that right now, not everybody's able to. So whenever I do examples, I require you to write these down. And you're going to be glad you did, because they're part of your assignment. So we're doing them together. You don't have to do them on your own. We're doing them together. So now that we're ready to do examples from your assignment, whatever paper you're going to do your assignment on, get that out. You can just keep going on your notes if you want to. I don't care. Whatever works best for you. Okay? Either on a new piece of paper or just continue where your notes were, whatever, but write these examples down that we're going to do together. 10 minutes. All right, so our assignment begins on page 8. So flip to page 8 with me. And we'll start at the beginning. We don't always start with number 1, but we usually do. It says, use the figure to name each of the following. And so then they give us this figure. So look at the figure, and you don't have to draw the figure. There will be times later on where you need to draw the figure, but right now we can just look in the book or look at the screen. What I need you to do right now is just put the answers down. All right? These aren't even going to have any show your work kind of stuff yet. We will, but these today aren't. All right, we're supposed to name a line containing point X.
Would that be line M?
Excellent. So you find point X, it's right here, line M, right? Because we're talking about this line right here. Now, that's not the only correct answer. That's the only line, but that's not the only name for that line, is it? So, and all I need is one correct answer, unless they tell you list 5 or list 3 or whatever, or list all. Sometimes I'll say name all. But if they don't, one's okay. But look, I want you to see the rest of these. Line XY would be a correct name, wouldn't it? Which means line YX would be a correct name. What else?
I was going to say, can it be all 3 of them? Or
just use 2. Don't call it line XYR. Just use 2 points. But it can be line XR or line RX. And look, you can even do this. You can even call it line YR. That's the same line, isn't it? It's still that one I put in red. Or line RY, and I think that's all of them. And again, I'll take one correct one unless it tells you to list all of them or 3 of them or whatever. But any of those would be correct. Number 2, a line containing point Z. Oh, look where Z is. Is Z in the same plane with all those others? No, it's not. But that doesn't mean you can't draw a line through it. Now this drawing, you need to understand what this drawing is trying to tell you. Here's what's going on. Plane B is that yellowish beige colored plane there. What this is trying to tell you, I'm getting ready to outline here, what this is trying to show you is that you have a plane, like this piece of paper here, and line L is not in that plane, it goes through it. Right? Line L starts up here, goes through the plane, and comes out the bottom. So it starts up here, it meets the plane right there at point R, and then the little dotted line is trying to show you that the line's still there, you just can't see it anymore. You can't see it because it's underneath that plane. See what I'm saying? So a line that contains point Z could be line L. What's another name for line L?
RZ.
Yep. Line RZ. And can I reverse the Z and the R? Yep. Line ZR. So you understand what that figure's trying to show you? Okay, good. And now we want a plane containing points W and R. There's W, there's R. Well, they're both in plane B, aren't they? Okay, they're in that beige colored plane. So all we have to write is plane B. Now, that's not the only name. I can name that plane any three non-collinear points. Any 3 points not on the same line. So I could call it plane what? YWR. And then all the different orders of YW and R, right? RWY and everything else, which I'm not going to make you write. All right, so far so good? Okay. Number 4. Here they're giving us a model, and we're supposed to tell the geometric term. So name the geometric term modeled by each object. A beam from a laser. Would that be a point, a line, or a plane? It's a line. It's a line. Now, here's the weird thing about that. If you've ever seen like a laser pointer, like we used to have a cat toy that way, where you shine a little laser on the floor and the cat would chase it. Okay? What you see once the laser hits an object is you see a point. But the laser itself, the beam, like it says here, is a line, isn't it? Okay, so good. This is easy. What's a floor? Yeah, it's a plane. The flat surface. So now, is a floor actually a plane? No, because it stops. And most floors aren't actually flat. They're flat-ish, but you get the idea. Okay? Ooh, we could call it a ray because it does have an ending point, a starting point, doesn't it? They're wanting us to say line because we haven't talked about rays yet. I like your thinking. I like that. Nicely done. All right, we ready to move on? Number 6. Now, I've got a coordinate plane up here. Now, I'm not going to cheat. I'll take that away. Because we're going to do some graphing this year, but not a whole lot. If you want to buy some graph paper, you can, but we're not going to use it all that often. All right, so I don't need graph paper. It says draw and label a figure for each relationship. So we're supposed to draw and label a line in a coordinate plane. Okay, coordinate plane. So make your coordinate plane. And we're going to draw and label a line that contains A with coordinates 0, -5. So start at the origin. X coordinates 0, so don't go anywhere left or right. Y coordinates -5, so 1, 2, 3, 4, 5 down. And that's where point A goes. So make the point and then label it A. And B is 3, 1. So go back to the origin. X coordinate of 3 means 3 which way? To the right. 1, 2, 3. And then 1 what? one up. And that is point B. And notice it doesn't matter if you put the capital letter to the left or the right or above or below. Just put it wherever it seems convenient. And point C that is not collinear with these two. Well, so look, don't write yet. Should I put point C right there? No, because it looks collinear. It may not be. It may be off just a bit, but it looks collinear. So don't put it there. Put it, here or way up here. So, I mean, make it obviously not on the line. Don't put two of them on there. Just put one. But make sure that it's obviously not on the same line as A and B. Okay? That's it for number 6. Any questions yet? All right, we're doing well. All right, number 7. Yeah. I can put it anywhere as long as, like if I drew a line between those two, since point C is not collinear, point C just has to be somewhere else. So I could have put it up here just as well. Okay? All right, we're supposed to draw and label plane Z. All right, plane Z. Make the little parallelogram shape and put Z in one of the corners. Plane Z contains lines X, Y, and W. Lines X and Y intersect at point V. So I'm going to draw a line X. So there's line X. Now line Y intersects it at point V. So let's draw, I don't care where you draw line Y, as long as it intersects line X. So I'll call that Y. And we're supposed to call the point where they intersect V. So there where they intersect, I'll make that point a little bit bigger so you can see it, and put a V. It doesn't matter where the V is, as long as it's near that point somewhere.
What is it? Is that a Z or a C?
It's a Z. When I put lines through them, they're Z's.
So it's like plane Z?
Yep, exactly. Now, lines X and W also intersect. So I need to draw another line that intersects line X. So there's a line that intersects line X. I'll call it W. And what do I need to call their point of intersection? P.
Would P and Y end up intersecting on this way?
We don't know. So, doesn't matter. All right. We doing good? That's fine. Doesn't matter. All right, back to page 7, right above example 4. They give us another definition. Space is defined as a boundless, three-dimensional set of all points. Space can contain lines and planes. Does. Space does contain lines and planes. All right? So for a mathematician, all of space is filled up with points. And if there are points, there have to be lines and planes. So that's what space is. Now, look here at numbers 8 through 11. 8. How many planes are shown in this figure? Well, look, let's count them. Look up here at the screen with me. I'm counting flat surfaces. Wouldn't this triangle here be a flat surface? And the triangle at the other end would be another flat surface. That's 1, that's 2 so far. Wouldn't this rectangle here be a flat surface? Wouldn't this rectangle on the bottom be a flat surface? And then we've left out one. What have we left out? The back side. So altogether, that will give us 5 planes. Name 3 points that are collinear. What are 3 points that are collinear? And now don't make the line symbol. Collinear, I mean, I know they're on a line, but we're not listing, not in a line, we're listing the collinear points. A, B, and H. Does it matter what order I write those points down? Not at all. Is there another answer? Yeah, B, J, and F. And again, you can put them in whatever order you want. Number 10, are points A, H, J, and D coplanar? There's A, there's H, there's J. They're coplanar. They're all in this rectangle right here, aren't they? And then there's D. Is D in that same rectangle? Nope, it's back behind it, isn't it? So, are they coplanar? No. And then explain. D is not on the same plane. All right, 11. Are points B, D, and F coplanar? They are. They're all on that little triangle in that end, aren't they? So this time the answer is yes. The explanation is they are on the same plane. You can say on or you can say in. Doesn't matter. The points on the plane, the points in the plane mean the same thing. Okay? All right, we've got one more example to do. Number 12. The directions, or the problem says, Ursa Minor, or the Little Dipper, is a constellation made up of 7 stars in the northern sky, including the star Polaris. So look at the little map over here. They have Polaris, and then they just number the other stars. They don't name them. It says, what geometric figures are modeled by the stars? Now, we've got to be careful. The actual stars are not in the same plane, are they? Okay? They look like it, but they're not. We can draw lines through any two of them, can't we? Okay? But what the book wants you to put is that they model a plane, and that's just not correct. Okay? So what I want, and they say by these stars, so that makes me think they want us to think of all of the stars. So the book wants you to say plane, but I'm not happy with that. So I'm going to say they look like a plane, but they are not really coplanar. That way I'm answering what the book wants, but I'm also, you're letting me know, hey, I know in reality they're not all in the same plane.
Do you think the book's just talking about the pictures?
Well, here in Part B, I think they are, because in Part B they say, are star 1, star 2, and star 3 collinear on the constellation map? So I think they might have just left the word map out of Part A, okay? Because if you look at that map, it is a plane then, isn't it? The map's flat, okay? So 1, 2, and 3, there's star 1, there's star 2, there's star 3. Are they collinear? No. They're not all in the same line, are they? They're coplanar now that we're talking about a map, but they're not collinear. B. No, they are not in the same line. Making sense? Last one. Are Polaris, star 2, and star 6 coplanar on the map? Are they all, you're overthinking this. Are they on the same flat surface? Yes, they're all on the map, they're all on that screen, aren't they? They're not saying are they really in space. On the map, they are coplanar because they're all on that screen. So, yes, and they don't ask for an explanation, so I won't give them one. Yes. All right. Yeah. Yep. All right. They want to know if 1, 2, and 3 are collinear. 1 and 2 are. They're on the same line. 2 and 3 are. They're on the same line. But you can't get a line that goes through all 3 of them. it would have to curve. So that's why it's no. Does that help? And, oh, one other definition that you'll run into, it's in the reading when you're getting to a problem, but nobody ever reads the directions. Huh, imagine that. A locus is a set of points that satisfy a particular condition. So it's just a fancy word that means set of points. Okay? A locus is a set of points. When you get to the problem where that's involved, you'll understand what I'm talking about. And there's your assignment.